This is Unit 9, Kinetics and Equilibrium. Lesson 5, Le Chatelier's Principle. How do stressors impact chemical reactions? The objectives of this lesson: I can determine the shift in equilibrium when a stress is placed on a system. I can determine the change in products and reactants when a stress is placed on a system. Do now. Le Chatelier's principle is this. If a system at equilibrium is subjected to a stress, the equilibrium will shift in the direction that relieves that stress. This causes a change in concentration of both the reactants and products until the equilibrium is reestablished. Le Chatelier's principle is essentially about restoring balance. If you add more to the left side, the reactants, the lever will tip to the left. So if I add more here, it will go down. In order to restore the balance, the system responds by making more of what is on the right, the product side, and vice versa. I'm going to add more to put that lever back down. There are three types of stress: concentration, or adding more or less of a product, the temperature, and pressure, which applies only to gases. So how do you determine the equilibrium shifts? So you're going to use a trick. If it's A, it's away. If it's T, it's towards. So when you add a stress, the equilibrium shifts away from the stress to the other side of the reaction. When you remove or take away a stress, the equilibrium will shift back towards the side that decreased to replace it. So for example, if I add a whole bunch of N2O4, my equilibrium is going to shift away, and I'm going to add more of what's on the other side. And this will decrease. So this will go down while these will go up. And we can see that visually using this. If I have a low amount of NO2 and a high amount of N2O4, I'm going to decrease my N2O4 and increase my NO2 until an equilibrium has been achieved. What is equal at equilibrium? What is not equal? So this is a summary of concentration. I'm not going to read through it. It's in your notes. So you should read through this now. And an example, if I increase the concentration of a reactant, so for example, if I have a lot more CO2, so I'm going to add my CO2 or increase this, CO, I'm sorry, just CO. The trick is I'm going to move away from anything I add. So I'm going to shift the equilibrium to the right. Everything on this side is going to go down. I'm going to decrease what's here. I'm going to decrease what's here. And everything on the other side will go up. My energy will not change at this time. If I increase the concentration of reactant, here is a visual representation of that happening. At the beginning, I have CO, CO2, and O2 in equilibrium. However, I added carbon monoxide right here. Therefore, I have an increase of that. My equilibrium shifts where my CO will go down, my O2 will go down, and my CO2 will go up until a new equilibrium is reestablished. If I decrease the concentration of a product, so for example, if I take this stuff away, I'm going to decrease this, I'm going to shift away, I'm going to shift towards what I took away. So the shift is going to be in the same direction, and these reactants will decrease, and my CO2 will increase. So if I take this away, my equilibrium will shift. So stop and think. Now in temperature, here's a summary of temperature. I'm not going to read through this. You should take a minute and read through it in your notes. And an example, when I'm talking about temperature, now my heat is important. So if I were to increase the temperature, what happens is I'm going to shift away from the energy side. So when I increase the temperature, I'm just increasing the temperature of everything, and I will shift away from my heat because that's my temperature. So my equilibrium will shift to the left, which means I will increase my reactants and decrease my products to reestablish equilibrium. If I decrease the temperature, so I'm taking it away, I will shift towards it. So I'm going to decrease my temperature, which means I'm looking at my energy. So I'll shift towards my energy, which means these will decrease, as I shift away, and this will increase as I shift towards it. So stop and think. Now, pressure applies only to gases. And one difference thing here is we're going to be talking about the moles of the gas, which means our coefficients. So take a minute to read through that. Okay, so if I increase the pressure, what I'm going to do is I'm going to shift away from the side with more moles. So this is one where I need to. So when I'm talking about the moles, I'm going to add up the total coefficients on my products and my reactant side. So on this side, I have 2 plus 1. So I have 3 moles on this side, 3 moles on this side, and 2 moles on this side. So if I increase the pressure, I'm going to shift away from the side with more moles. Therefore, I will shift away from the 3 moles, which means this will go down, this will go down, and this will go up. If I decrease the pressure, I'm going to shift towards the side with fewer moles, the side with fewer moles. So in this case, I've got 3 moles on this side, 2 moles on this side, and if I decrease the pressure, I'm going to go toward the lower amount. So these will go down, and these will go down, and this will go up. So pressure is a little bit different. So you should probably make note to really study this one because it's a little bit different and it can be a little confusing. So stop and think, look through these questions. And finally, the catalyst has no effect on equilibrium because both the forward and reverse reactions will be affected equally. So both will speed up. I'm going to skip that. Example. Let's do an example and a practice, and then we're done. So if the concentration of CO is increased, what direction will the equilibrium shift? So remember, if I add something, I'm going to move away from it. So the equilibrium will shift to the right. What happens to the concentration of CO2? If I'm shifting towards it, it's going to increase. What happens to the concentration of O2? If I'm shifting away from it, it's going to decrease. Okay, now practice. You try these on your own, and I will go over them in class. And check your understanding. And now I can determine the shift in equilibrium when a stress is placed on a system, and I can determine the change in products and reactants when a stress is placed on a system.